Yeah, we're continuing our wonderful journey into the world of PDFs with finding modes, medians, means, standard deviations, all that stuff. Okay, so we got this PDF here. First things first, we better actually check that this thing is a PDF. So for checking that, just as a reminder, f of x would have to be positive for all x values, and it looks like it is. I've just graphed it here. And between 0 and 2, it absolutely is positive. So I might just make a little point of that for 0, because it does go negative before 0. So yes, it is, because it's clearly above the x-axis. And for 2, we really would like that the integral from 0 to 2 of f of x dx was 1. We'd like the total area to be 1. And we can check that. So go on the integral here. And we're going to go from 0 to 2. And what do you know? It's 1. So yes, with technology. So just really important, if it's a show that question, you actually should give some more explanations. So you could go like above x-axis when graphed. And if this integral was a show that question, you should do all the definite integral working, which I really recommend practicing. Okay, next up, find the mode. So the mode, the way we find that is it's sort of the value which maximizes f. So if I had a graph of f here, this value here would be the mode because it's the highest value on the graph. So usually you'll just be doing G-solve max. In our case, it's a little bit different because we don't have like a local maximum. We just have a maximum on the very right here. It's that last value of x. So just to verify that is 2, yes. So the mode is 2. That's the mode. It's the x value which maximizes the function. Okay, find the median. Median is always the worst one to find. You have to do the integral by hand. So basically what you would really like for your median is we want to find the m value such that when I do the integral, it catches exactly half the area. Now, fun fact, the area over here would be 0.5 as well. But the important thing is the median catches half in the first half. So what we want is that a half should equal the integral from the starting point. In our case, we start at 0, all the way up to the median of our function. And that's how we find the median. It's a little bit tricky to do this calculation. You do have to do the integral by hand. So half equals the integral from 0 to m of our function was a half x. Make sure I actually got that right. Yes, I did. Okay, so a half should equal, so it's half x squared over 2, if you like. So x goes up to x squared over 2 and the half stays out the front from 0 to m. But if you want to simplify that down, that's a half equals... I'm going to pull the quarter out the front because 2 times 2 on the bottom is 4. And then I'm just left with x squared in here from 0 to m. So let's see, a half. Now I can times both sides by 4 if I want. So 4 over 2 is x squared from 0 to m. So 2 is x squared from 0 to m. There's lots of ways you can do this algebra. This is just the cleanest way that I found. So you've got m squared take 0 squared. So 2 is m squared, or in other words, m is going to be plus or minus root 2. Now, really importantly, the range for x values can only go from 0 to 2. So our median is just positive root 2. Therefore, m is root 2 as x had to be in between 0 and 2. So it can't be negative. Now, really important, you check this. So if I go G-solve and integrate from 0 to root 2, I should get half of the integral, which I do. So that's really good. Okay, now I promised that was the worst one. Now we're going to find the mean. So there's a formula for this. The mean is the integral Well, it's the integral across the whole bounds of x times your function. So in our case, that's 0 to 2 of x times the function. So yeah, don't bother doing this on your graph. What I want you to do is jump out into math mode. So let's go through integral. We're going to go x times, and then we're going to do the function. So that is half x. We're going to go from 0 to 2, and our mean is 4/3. So it's 1.3 recurring is the mean. Variance has another formula. Well, there's actually two formulas for it. Conveniently, these are actually on the SACE formula sheet as well. So it's either x squared f of x take the mean squared, or the other formula is sort of all bundled up, x take the mean squared times f of x. I'd really encourage you to think about maybe why these are equivalent. If you sort of just expand this out, you don't quite get to the thing on the left, but you do get something close, and you can use some stats facts to figure out why they're actually equivalent. Generally, I like this formula better, and I like this formula worse. The only reason is sometimes with this formula, I forget to take off the mean squared right at the end. It's very easy to miss that bit. But I'll show you how both of these formulas work. So that is the variance. Okay, so this would be the integral from 0 to 2 of x squared times half x, because that's a function. Take the mean squared. We need to know what the mean is. That's 4/3. So we're just going to plug that in, 4/3 squared. Okay, let's see what we get. So integral, we're going to have to put what we need in the integral. So that's x squared times a half x. I wouldn't even bother trying to simplify this down before you type it in, because you may make a mistake. You don't want to risk that. From 0 to 2. And this is the bit that I always forget to do. You have to take off the mean squared once you're done. So take off 4/3 squared. That's why I don't really like this version. I always forget to do that. It's 2 over 9. So it's 2 over 9, which roughly equals, and we can get an approximate for that, 0.2. I guess since it's recurring, I can say strictly equals. Same thing for that one. That's technically a strict equals sign. Okay. Now I'll show you how the other method works. This is 0 to 2, x take 4/3 all squared times the function half x. We'll see how that works. So if we do that, let's see, integral. So it's x take 4/3, square it, and then timesing it by a half x. And we're going to integrate from 0 to 2, and I should get the same answer. So 2 over 9, or exactly equal to 0.2 recurring. Groovy. All right. So yeah, use whichever one you're comfortable with. Find sigma. So you might not have seen variance before. Basically, the standard deviation squared is the variance, or if you want, the standard deviation is the square root of variance. So that's how those two things are related. So sigma is literally just the square root of the variance, which we just worked out. So it's square root of 2/9, which we can just pop into our calculator. The square root of answer, root 2 over 3 if you want. But since we're in stats, we're usually doing real world problems, so they tend to like decimals. So we better convert that, 0.471. So that is the standard deviation. I'll point out that you can actually do all this to work out standard deviations and means for normal distributions. It's just the function for a normal distribution is really messy, so that's why we don't